Good morning, and welcome to this presentation of from MPAI. Actually, it is the first of a set of 8 paired presentation on standards and the call for technologies that have been approved by the last General Assembly. So moving picture audio and data coding by artificial intelligence, MPAI, the organization that is performing this presentation, is an international, unaffiliated, non-profit standard developing organization. It develops AI-based data coding standards, but not just that. It also strives to attach a clear intellectual property rights licensing framework to its standards. MPAI is an organization. It is registered in Geneva, Switzerland. It has an organization. Essentially, the General Assembly is the body that decides and performs all the functions in the MPAI. The board of directors is the usual entity with some other committees. Essentially, the standards are developed by developing committees. We have 6 of them. Then we have also a requirement standing committee where standards are prepared. We have a very rigorous process to develop MPAI standards. So you see that we start with interest collection, we develop use cases, we develop functional requirements and commercial requirements. When both are ready, we can call for technologies, we receive proposals, and we develop standards. When the standard is closer to approval, like it is in this case, we publish the standard for community comment, and after that we have the technical specification, reference software, conformance testing, and performance assessment. So what is the real purpose of MPAI standards? So we wanted to enable humans, users, to select machines whose internal operation they can understand. So you have already a lot of AI applications, but you know what you give in, and you see what you get out. But how this output information has been produced, you have in general no ideas. We try instead to give humans the ability to understand what is happening when something is produced. And we do that by breaking up a monolithic AI application into interactive components that exchange data with known semantics, at least to the extent that this is possible. And therefore, developers can compete offering improved performance standards components. And so this is the summary. And our standardization is component-based. We divide an AI application into AI modules that are aggregated in one or more workflows and executed in a standard environment. And this standard that you see here is exactly the specification of that environment. So this is the reference model for AI framework. You see here we have a number of AI modules that are differently interconnected. We have the controller. The controller can obtain security support through this security abstraction layer. Currently, we have communication services, encryption services, and attestation services. And the AI modules as well can access this SAL layer. Second standards. MPAI standards create an ecosystem. The ecosystem is composed of developers, and they require interoperability to be able to bring their components to the market. Integrators, they assemble components and make an application. And they, of course, require the ability to assemble components that are potentially coming from different parties. And finally, consumers. They are just the users of the assembled components, the application, and they require that the assembled components be trusted. Therefore, we need an entity that guarantees that the components are interoperate, that is trusted, and that they are actually available when they need it. Therefore, you see the second standard that we have development that is called the governance of the MPAI ecosystem. So what is exactly the MPAI ecosystem? So we have MPAI developing standards. The standards are taken up by implementers. MPAI appoints assessors, performance assessors, so that when an implementer submits an implementation, the assessor can say, okay, this has the required performance or not. MPAI has also established the MPAI store. It is a non-for-profit organization registered in Scotland. It verified the security of submissions. It tests their conformance and checks the performance, but does not execute the performance because that is done by the performance assessor. And it is this okay from the performance assessor that says that performance has been checked. Then the implementer submits an implementation. The implementation is posted to the MPAI store, and end users can download an implementation, and they can communicate to the MPAI store their experience of these applications. But we have many more MPAI standards that have been published. So we have 4 technical specifications on audio enhancement, on financial data, on multimodal conversation, and the neural network watermarking. We also have 2 technical reports, the MPAI Metaverse model functionalities and another one on functionality profiles. The work that I will present today is largely based on these 2 technical reports. But last General Assembly, MPAI has published 5 standards for community comments. We intend to publish the final standards on 29 September 2023. So here you see who they are. We have extended 2 MPAI standards on the AI framework and on model conversation. We have also developed new standards on avatar representation animation, connected autonomous vehicles architecture, and the MPAI Metaverse model architecture that I will be talking about today. But this is not the end. We are more brewing in the pot. We have decided, last General Assembly, to call for technologies for 3 areas. 1, artificial intelligence for health, object and scene description, and extended reality venues, the particular case of live theatrical stage performance. We are also exploring new opportunities on video coding. The first is AI-based end-to-end, and the second one is AI-enhanced video coding. And we have also an activity, exploration activity on gaming. Last point, 4 of our standards have been adopted by IEEE without modification: the AI framework, the audio enhancement, multimodal conversation, and the financial one. And we have a 5th that is on its way to becoming an IEEE standard. So I'm proud to announce that all this was achieved in less than 3 years. So welcome to MPAI, but more precisely, let me welcome to the presentation on the MPAI Metaverse model architecture. So we are working on the metaverse. You may ask, why is MPAI interested in the metaverse and working on it, even producing an architecture standard? Well, it's because there are definitely an interest in industry, in the metaverse, because we expect that there will be new jobs, opportunities, and experiences. Standards and AI are the main drivers for the development of the metaverse, and MPAI is about standards, of course, and is also about AI data coding. Standards are needed for the metaverse, and MPAI has already a few that are a response for these needs. But of course, this is not the end of what the metaverse will require in terms of standards, and the MPAI has the intention to continue to develop some standard, not necessarily related to the metaverse, but a few will be. And finally, the metaverse is an excellent platform for technology integration. We have a few standards. We are developing reference software, and we are already integrating some of our technologies into an implementation of the metaverse. So the magic word today, when you hear about metaverse, is interoperability. And it is really important that we define what is the meaning of interoperability. So we have the first case when we have prescriptive interoperability. This is as we have in media. And so let me see what it is. We have a metaverse instance number 1, a metaverse instance number 2, and we have a standard format that is used to communicate. So this is ideal, but not realistic, in the sense that the metaverse context is fast evolving, and the technology has many configurations, many possibility of usages, and freezing technology for something may not be advisable in some cases. We have a second case when everybody for himself. I mean, I make a metaverse instance, and I just decide what I need and what I do without taking care of what other people may be deciding at the same time, because they are also developing a metaverse instance. In this case, let's just see what we are talking about. So we have a metaverse instance 1 that produces data with format 1. We have a metaverse instance 2 that produces data with format 2. So we have a format conversion service that takes format 1 and converts it into format 2, and takes format 2 and converts it into format 1. So this is good, but interoperability is not guaranteed for all cases, for the reason that I will explain in a second. In general, data format conversion is possible when the data formats reference the same functionalities. So this is the case. We have data A for metaverse A and data B for metaverse B. If the two have the same functionality, they may be represented by different technology, but conversion is possible. But in the general case, this is what happens. We have the data from metaverse A, and okay, this can be converted to a data set from metaverse B, and another data set from a metaverse B again, but there is other data that do not have a representation in metaverse B. So this is the problem that we have, and therefore we should specify the functional requirement of the data provided by an instance to another instance or to a device, and the operation model of an instance. So this is what is the core of what the MPAI metaverse model architecture is about. Therefore, functional interoperability enables the conversion of data with the format of an instance A to the data with the format of an instance B. Let's see the structure of the standard. We have an introduction, we have the scope, we have definitions, we have references, we have metaverse functionalities, metaverse operation model, And then we have the functional requirement of processes, actions, items, data types. Finally, we have use cases and functionality profiles. The meaning of these words are partly clear, but I will certainly explain them one by one. So let's talk about the introduction. So we specify the operation model of an instance, the functional requirement of processes, actions, items, and data types. Then also the protocol that enables a process in an M instance to request a process in another M instance to execute actions and items, and the functional profiles supported by an M instance. So this is the introduction, the scope. So these are very, very clear words. I hope they are, because the architecture enables interoperability of two or more M instances if they rely on the same operation model that is specified by the architecture, and they use either the same technology, this of course is very desirable, or independent technologies, and they use a conversion service to make the appropriate conversions. The third requirement is that they should have the same profile specified by the architecture. Profile means that they are selecting the same functionalities as specified by the state. Terms and definitions. Terms, of course, are important for any standard, but they are more important for a functional standard, because we are not specifying technology, we are specifying functionalities. And therefore, we have collected about 100 metaverse-related normative definitions. The definitions are normative. Then we have 3 normative references: the statutes, the MPAI patent policy, and the framework license. I will talk about it later. Metaverse functionalities. So this is a set of elements. So we have essentially reviewed the content of the technical report on functionalities, and we have organized it in a way that allows us to derive from the functionalities the organization of the metaverse instance, and also the functional requirements. So we have here a kind of definition of an instance. It senses data, it processes the data, produces item, it produces an environment populated by imported or internally generated items. It processes objects to make an impact on the real world or the virtual world in ways that are consistent with the goals set for the M instance, affected within the capabilities of the M instance, in compliance with the rules set for the M instance. So we start with defining what are the functionalities that we need. So we make an assumption that inside a metaverse we have processes, and we identify 4 types of processes: the device, that is what connects the real world with the metaverse; users, which are the representation of humans in the metaverse, but potentially also on devices; the application running on devices; and the service that generate functionalities. Then we have a certification, and we are talking about processes. Some processes are native, but some processes may be imported. In that case, we need a certification. Same for contract, which are a particular type of process. We have the issue of registrations. What does a user when it registers? It has to request it to provide a certain information, and the metaverse generates an account. Then there's an issue here that it's desirable that the personal profile has a scalable representation so that I can easily extract the subsets of the personal profile. Then we have users. So what are users? Users are not avatars. The users are processes, we said, and they represent the humans, and they act under the responsibility of the human and may be rendered as persona. We use this word as a replacement of avatars. And the persona may be a faithful reproduction of how the human looks like, or a changed appearance, or an unrelated visual appearance. They may display a personal status. This is MPAI technology that is very useful in association with processes, and can be driven by the movement of the human. So I'm moving here, and you see my persona that moves like me, or my persona can be animated by a process that I have selected. We have the notion of identifier with several requirements for identifiers. And very important, we have the roles. So here we have a collection of roles that concern the user data, the rights of obligation of the users, the permission in accessing, or permission or lack of permission in accessing a metaverse environment, trusted relationship between users and an instance, the subset of user data, the sanction that can be applied to a user that does not behave. And of course, this is not the end, but it is an initial list of the rules. Very important, we have, again, the notion of process, in the sense that the process is not just acting on itself, but it may request another process to do something for it. Therefore, the user may formulate the information that it intends to obtain from a service. So, for instance, I'm making a request to a service to find a type of information that I need, and I express also the rights that I'm ready, I wanted to acquire on the response to the service, and how the response to the service should be rendered. The rights may include a certain number of issues, and they can include the ability to create scenes that are persistent, to store, search, and retrieve experiences. Experiences is what a user has perceived at a certain location at a given time, develop economic activities, book a location, support persistent storage, connect with or import processes to an M instance, and make transaction to acquire rights. So now we are coming into another set of rights that concerns the perception, the fact that I can perceive entities, can perceive scenes, import audio, render, receive messages, import the data and metadata. Then we have the functionality that concerns the interaction related rights to perform something. So it can interrogate the process about its functionalities, interact with entities, send public or private media to users, send selected entities to a user, place entities with spatial attitudes, and animate models. Then we have the rights to call a service. For instance, we wanted to author an item. We want to authenticate an item. We want to change the rights of the process. We want to discover objects, processes, event experiences. We want to find a transaction that involved an asset. We want to obtain an interpretation of an item. And here we have a first set that makes reference to an MPAI technology, which is the personal status. And here again, another series of rights to obtain the conversion of an item from a format to another format, get information about the process, get recommendations, record all the actions made by a user, create a representation of the network of connections, post an item that can be transacted, so an item with a value, retrieve objects, store objects, and Then a user may have the right to perform or request another user to perform action on an item, develop an economic activity, make an asset out of an item. So I have an asset and now I want to sell it. I have an asset, an item, and I want to make it an asset. I make a transaction. I can make an agreement with another user, copy or modify an item, change the settings, set the point of view, make an item inaccessible, make or request a process to make an item on in its own or another instance, and can be rendered as one of the account persona. Finally, a location in the metaverse can be public, persistent, ephemeral, and obviously maybe virtual, digitized, autonomous, and have audiovisual or haptic attributes. These are three senses that we consider in this architecture. Finally, an M instance can operate in a centralized or decentralized way, can monitor the rights of a process, the entities, should be secure, and should withstand the denial of service attacks. So this is a general collection of functionalities that we would like an M instance to support. So these have been converted into an operation model. I will not go into the details of the operation model because this is really a reflection of the functionalities that I have explained. So we have what an instance definition, then some functionality that you see here, then the fact that a process must be identified by an ID, by the ID of the user that has a right to act on the process, in rights ID, which is the ID of the user right the right that the user has to act on the process, and how many rights another user can acquire, and metadata. So this is very basic in the sense that a process has as a minimum this is a set of metadata. Then we have finally the specification of the format that is used by a user to request an action, and how the other user or the other process can respond to it. And here are the details about the meaning of all these items here. Then we have more functionalities of the operation model. This is the protocol whereby a process in a metaverse instance, that call it process A1, is able to request a process B1 to do things for it. Of course, there are many elements, the fact that there are different domains, different security, but this is the basic protocol. Then we have the type of processes that we have already described, the device, user, service, and app. And this is a very clear model. We say that here we have a human on the left-hand side, then we have the device. The device can support applications, but can also support users. Actually, a user is a specific application that is running on the device. Then we have the user, and as I said, the user is a process, and it is represented as such in the metaverse. And the user can be rendered as a persona and can communicate with other processes. So this is another specification of the metadata for an item. It's very similar to the process. And here we have more elements. The fact that it gives, for instance, a registered human the right to deploy users or devices, but also persona. It also establishes the rules for the instance. And a metaverse may penalize a user for lack of compliance with the rules, and more issues. So all this has been converted into action specifications. So this was the operation model of the architecture. So we say, what is the purpose and what are the functional requirements of an app? What is the purpose, the functional requirements of a service? Same for devices and same for users. So this is structure in purpose, functional requirements, and metadata. I've not reported metadata here because it would be too heavy. But you know, this structure is common across all the specification of the Metaverse architecture statement. So here we have finally we have mentioned actions. So this is the overview of the types of action that we consider: general actions, the action of calling a service, the action of managing entities, items, from the metaverse to a metaverse, from the metaverse to the real world, and from the real world to the metaverse. This is the classification of actions. And you know, here you have quite a long list. So you have register, change, hide, authenticate, identify, modify, convert, verify, request, respond, execute, author, discover, inform, interpret, post an asset, transact an asset, request a resolution service to communicate. And then we have the actions about placing items, making items visible, making item invisibles, animate a model, send an item to a process. And you know, we have more and more. This is quite elaborate and complete, I believe. Finally, we have items. So here we have general items, human and users related items, item for process interaction, item for service access, finance related items, perception related items, and space related items. So again, here you have the similar structure. What is an instance? What is an environment? What are identifiers? I mean, in terms of functionalities and purpose. What is a program? What is a contract? What are rights? What are capabilities? Capabilities for a process before it was for the metaverse instance. Then we have the specification of the request of action and the response action. What is an account? Activity data, personal profile, rules, social graph, user data. These are financial, asset, ledger, provenance, transaction. So this is the full specification of a transaction. What is a value? What is a wallet? Then we have accessing the service. So this is made by a user sending something that has the suffix in, and the service responds with the same word and the suffix out. So we have authenticate in and authenticate out, discover in, discover out, inform in and inform out, interpret in, interpret out. Then we have entities. Entities are items that can be perceived. So we have event, experience, object, model, persona, scene, stream, interaction, map. This is useful for particular applications. What is an M location? What is a U location? Then we have the functional requirements of data types. So these are more general data that are not items. So what is an address? What is time? What is currency? What is amount? Coordinates, orientation, point of view, position, spatial attitude. And then we have the representation of the internal status, cognitive state, emotion, social attitude, and personal status. Then, this is very important, so we have collected a number of use cases, and we have verified that the specification that we have defined in terms of actions, items, and data types can actually be able to implement these use cases. So these are the areas of metaverse applications. These are the in-depth analysis of use cases. For instance, train a metaverse hospital staff. So we have made a complete analysis. Then we have expressed the use cases with means of description, processes, items, and location that are used, the workflow and actions, then actions, item, and data types. It is pretty complete to verify that we have all the technologies needed to represent these use cases. You see them here: virtual lecture, virtual meeting, hybrid working, esports, a tournament, virtual performance, AR tourist guide, virtual dance, virtual class, car showroom, drive a connected autonomous vehicle. This is another MPAI standard, and we have combined the two. So this is how we are able to represent one use case, the one of the virtual dance. Here we have a teacher. The teacher actually is offering lectures of and practice of dance, exploiting some haptic technologies. I don't have the time to review that, but you see that here we have the teacher in the metaverse, and then we have a student one, and then what happens after the user one has come in, the student. Then we have another user, how the teacher is able to continue training of student one while actually train student two. And finally, the closure of the use case. Functionality profiles. This is something that we have done for the purpose of defining subset of technologies that can be used in an interoperable way without using the entire set of functionalities that we have identified here. So we have identified the baseline profile. We have identified a separate independent finance profile. Then we have identified the management profile that includes both, and finally a high profile that includes all the functionalities. So we have the baseline profile. This is the simplest one. This one has been designed to not require all the structure of rights and other things. And it can be used to support the basic forms of lectures, meetings, handout. We have also identified levels. We have the audio-only level. No one has should say that a metaverse should have necessarily avatars around. Then we have audiovisual and haptic. So these are three different levels within this baseline profile. So this is what you are supposed to be able to do with the baseline profile. You can read ISM data, you can identify items, author an item, and so on and so on. This is the full list. And this is the list of actions, item, and data types that are required to implement this baseline profile. Community comments. So you are requested to make a comment. The comments will reach the Secretariat by the 21st of September. You don't have to use a specific format, and we intended to use your comments to publish the final version of the standard on the 29th of September 2023. What do we intend to do after this work? So far, we have an OpenAPI-based client and server. We will soon be publishing the architecture API, and we are currently developing the table of content of a technology for metaverse technical specification. So we have a lot of work in front of us. It is for that reason that we look forward to working with you on this exciting MPAI project. Welcome to MPAI.